okay, in a solid software. How to do it? We are going to learn. So first position is in square of dimension 35. So thickness it is 0.50. Okay. So after this, we have to draw the diagonal lines to find out the center of the axis. Okay. So these lines has to be thin lines in case of prism. So we can dimension, mark the namings. Top face notation A, B, C, D, and the bottom face notations are A1, not visible, B1, visible, C1, visible, D1, visible, and we have center of the axis, that is O. So we have O1. Okay. So now projecting the lines, so we can draw the front view. So here axis length how much? It is 65. So I will take 65 axis length. Third line it is the axis length. So take 0.50 only here. So here 65. Yes. Also 65. So now we can write front view notations. C dash visible, but A dash similarly you can see B1 dash, the center O1 dash. And now the second position. So we have to copy this. Go to move, create a copy, then drag it along the line. So now see angle of inclination here it is 45 degrees. So we will go for the base edge inclination, that is 90 minus 45, it is again 45. So the same procedure, base edge inclination, we have to go here. Okay. First this, second this, and give the angle 45. Now we can see we can extend this axis and find out angle. Exactly 45. So that's how we are going to do. Okay. Now we will project it downward. So the bottom face notations you can write first A1, B1, C1, D1. This is O1. Similarly, we have this. It is D, and this is O. Okay. So herein, so we are not able to see this D1 and this D1 and C1. So that D1 and C1, it is written within bracket. Okay. Now the procedure for writing second position top view is, so first we have to draw an outer boundary line. So we follow the same procedure how we did in sketchbook. Starting from A1, B1, next to B1 to C, okay, next C to D, then D to E. So that's an outer boundary line. Now visible face. This square face visible from the top view. Okay, that is ABCD is visible. Okay. Then this B dash, A dash, and B1 dash, A1 dash also visible already in rectangle. So this bottom face not visible from the top view. So we can write part of it with the dashed line. Okay, then finally we have an axis. So we can show the axis from A1 to O. So you see in this the angle of inclination, that is 30 degree. So 30-degree angle line we have to draw here. So minus 30 degree angle line. So now we copy this. So we have to place it with respect to this resting edge. So we take it to this D1 point, and this is your projecting. So we will be projecting. Say first we will be top face this, and this top face will write the notations. Okay. So it will be ending here. B, so that B also ending here. This is C. You can just touch this C point and then okay. So the notations here it is A dash. This point it is B dash. This is C dash. This point it is D dash, and this is O dash. So now similarly we will write for the bottom face. Okay, so this bottom face and this bottom face we will write. First one it is A1. So A1 it is extended till here, A1 dash. So these 2 points are merging here. Similarly B1, so here exactly we get it. Next with D1, D1 it is on the XY line. And similarly we have C1, C1 also here till XY. Okay, now finally we have O1. 1 till here. Okay. So now we have to write down the notation for it. So this quantities d1 dash d1 dash d1 dash. Okay, now we have to write, take the nearest point here. The nearest point to exfoliate is D. So right here. Point to is D. Okay. Is with A, C, D1. So these are fine. So first we will construct the dashed lines. So dashed line from D to C, D to A, and D to D1. That is from D dash to A dash, D dash to D dash, D dash to C dash, D dash to A dash, and D dash to D1 dash. Okay. Now rest of the thing it is written with a continuous line. Okay. Now vertical edges from A dash to A1, C dash to C1, then B dash to B1, like this, and finally we have axis from O1 dash to O dash. Okay, see this. Okay, extra lines for there. We are going to trim it. Yes. So here, second position, angle of inclination, it is base edge inclination. This inclination it is base edge inclination equals 90 degree minus angle of inclination to HP, it is 45. So equals it is 45 degree. So that's what the base edge inclination in this second position front view. Okay, this is how we complete the problem. Okay. In this clear.
Good morning, all of you. Today we are going to start first problem in projection of solids. So with the prism. So we know that in the projection of solids we have to consider the right hand side reference for placing the base edge or the base corner. Okay. Say just for an example, say you can see that this is our pentagonal prism which is having top face and bottom face. So you can see that this is our base edge, okay, base edge, and this is our base corner. Okay, so we have to place it with the right hand side reference, and we know that our first position starts from the HP plane. Okay, so that's not the thing. So how the problem proceeds here, say consider, so this is our first quadrant. Say this is our pentagonal prism. Say I am placing with the right hand side reference. So right hand side reference means this side, okay, right side. First position, drawing the top view, front view. You can see that you have two faces, top face and bottom face. Then drawing the top view, front view. Second position, it is the inclination, right side inclination. Okay, inclination to HP and then top view, front view. Similarly, inclination to HP was already given, so it is inclination to VP. Okay, so understood, right? So it is what the inclinations, you can see that first position, inclination to HP, then inclination to VP, like this. So now we will proceed with the problem. Say in this problem we have to construct a square prism here, XY, VP, HP. So you can see that we have to construct a square prism. So of square prism of dimension 35 inside, of base and axis length 65. Rests on HP on one of its edges of the base. You can see that. So say consider this is your square prism. So this is having, we need to construct with the base edge here. Okay. So here we have to construct the right hand side. We have to construct the base edge. So if you consider a square prism, the top view, okay, the top view of a square prism, it will be in square, correct? Square, which is having top face and the bottom face. That means you need to construct a square here, square of dimension 35. Okay. Okay. So we have drawn a square here. You can see that. So in the square prism, we have two faces, top face and bottom face. So top face will give A, B, C, D, like that. If you take this duster, okay, top face A, B, C, D, which is visible to us, and the bottom face, which is not visible from the top view, it will be giving A1, B1, C1, D1. That will be in bracket. Okay. So the top face notations are A, B, C, D. Similarly, bottom face notations are A1 in bracket, B1, C1, similarly D1. Okay. So now this is what the top view, and there will be an axis here. Okay. There will be an axis connecting the top face center and the bottom face center. We need to find out the axis of the center. Okay. So how to find axis? And we will draw the diagonals here. So diagonals will be thin lines here. Okay, draw with the thin line. So here exactly the top face center O and bottom face center O1, which is in bracket. Okay, now we know that we have to draw the front view. Say if you consider this, this is as your square prism, then we have drawn the top view. Okay, top view of it with the two faces. Say when we are looking in the front view, we will get an rectangular face here. Okay, rectangular face. For that rectangular face, they have not mentioned anything. Instead of that, they will be mentioning a 65 mm axis length. Using the 65 mm axis length, we can draw the front view. So we know that axis center connecting the top face and the bottom face, which is having an axis length of 65. So by projecting, okay, these are the projection lines. Direction. So using the axis length, 65 axis length, I am drawing the front view. We know that front view is a rectangle here. So remember it, front view of a prism. The front view of a prism in the first position is always a rectangle. So first I am drawing an axis line here. So axis line of dimension 60 here. So first I am drawing an axis line. So which is having a dimension of 64. Okay. So using this axis length, I am going to construct the rectangle. Okay. So in the front view, we get a rectangle. Now we have to write the notation of it. So from the front view, we can see that. So from the front view, see, you consider this is your front view. So we can able to see from this front view B, B1, C, C1 visible, but A1 and D1 not visible, correct? So you can see that. So from the front view we can able to see these ends B, B1 and C, C1. So first I am going to finish with the top face. You can see that. So B dash it is visible, C dash that is also visible, but A dash it is not visible from the front view, and D dash not visible. You can see that this A and D not visible. Similarly, you can see that bottom face B1 dash which is visible and C1 dash which is visible, but A1 dash and T1 dash not visible. So similarly, you can write so O1 dash and O dash. So that is 1 thing. So now we have done with the first position, top and 20. So second position, we know that we have to give the angle of inclination to the right side. Okay, angle of inclination to the right side. So second angle of inclination to the HP, here they have mentioned 45 degree. So what is the procedure here to do it? So first we will be taking this reference point of C1 dash D1 dash reference point. By taking this reference point, using the protector, you can keep the protector here exactly and mark for here in the right side from here 10, 20, 30, 40, 45. So mark for 45 degree angle and draw an angle line here. Okay, draw an angle line. So that is for 45 degree. After say first taking the reference point and keeping the protector and marking up for 45 degree and drawing an angle line, what is the thing? Next you have to take the compass and measuring from C1 dash to B1 dash, you need to cut dark. Okay, you have to cut dark. This is B1 dash, B1 dash, and the second arc you have to cut it from C1 dash to O1 dash. This is O1 dash. Okay, so after cutting this arc, so this is the length we require, right? So this is the length. So after this, say we have been drawn the bottom part, okay? So these vertical lines we have to draw. You see that these three vertical lines are exactly perpendicular to this base line, right? So you have drawn the base. So what you do, you take the protractor, keeping at this reference point, you mark for 90 degree. So here you have to keep it the protector and mark for 90 degree. Similarly, you have to keep the protector and mark for 90 degree. After drawing the 90 degree, this length we know it is 65. Using a straight line scale, you can draw a straight line here. Okay. So draw the straight line. And then run it using a scale. So this is B dash, B dash. This is O dash, this C dash, D dash. Okay. So now, so you can extend this axis because the angle of inclination it is given with the axis. If you extend this axis and measure the angle, you will get exactly 45 degree. Okay. So now we will project it downward to complete the second position, top view. Okay, so for writing the notations, so you have to consider either the first phase first or the bottom phase. First I will consider bottom phase here. You can see that. So here they are merging. This is A1, this is B1, this is C1, this is D1, and this will be O1. Similarly for the top phase also, for this one also we can write. So this is A, and this is B, this is C, this is D, and this is. Okay, so you have done the namings. Now you see the concept here. So here it involves 3 steps to construct the second portion top view. First thing is you need to draw an outer line. Okay, remember it. So first we have to draw an outer boundary. You can see that I'm starting from this A1 point. So A1 to B1, so that's an outer boundary line. Then B1 to C, okay, B1 to C, so this is another outer boundary line. Then from C to D, then D to E1. So this forms an outer boundary, that is A1 to B1, B1 to C, C to D, C to A1. So that is the first step, outer boundary line. Now, with the second step in writing the second question is seeing for the visible faces and visible edges. Say we are looking this thing from the top view, right? Looking from the top view. So you can see this in this diagram. We are clearly able to see the top face of this sphere prism, right? That is top face. It is visible like this. It is inclined like this. We are able to see from the top view this face. This face is exactly visible from the top view. So that is. So this pair is visible, so we can join this ABP, so that is the square we get it. So similarly you can see that this edge B dash A dash B1 A dash, this is also visible, is already written with the continuously. Okay, that's what the second step. Second step is writing the visible faces and visible edges. Okay, now the third step is writing the hidden face and hidden edges. So you can see this bottom face not visible from the top. Okay, bottom face that is not visible, but already we have written a part of it. Okay, part of the square, but the remaining part we can show it with the dashed line here. Okay, so that's what a dashed line. So in this we cannot able to see this B1 and C1 here. Okay, that's what the thing. And then you can see that there is another this face also not visible, that is C1 D1 to D and C1 to C, but already we have written a continuous line. Okay, no need to show. Now you can show the axis line here. Okay, so that's what the axis line. Now in the third function you can see that, so you can see that one of its edges of the base which is inclined to VP at 30 degree. We know that in the normal type of problem, one angle of inclination will be there with the axis, okay, and then another angle of inclination will be there with the edges of the base. Okay, base edge inclination. So what we do, so we have to draw an angle line here. Okay, angle line here. So what we do initially, we draw a straight line here. Okay, smaller line parallel to the XY. Okay, parallel to the XY. So here I am marking the reference point. So you can keep the protector here, and mark for how much angle. So angle here given, that is 30 degree. So mark for 30 degree and draw an angle line. So draw an angle line. So this is 30 degree. So now what we have to do? So if say see that, so this is what the base is. Okay, this is CD1 D1. You can see in this problem also, we're inclining like this, inclining with the C1 D1. That's what the base is. So we have to take this base edge. You can see in the question also. So one of its edges of the base which is inclined to be at 30 degree. That is taking this D1 C1. So we have to make it resting on this angle line. Okay, how to do that? So I'll be taking first a reference point of D1 here. Okay, then using measuring from compass, measure from D1 to C1 and cut the this is dashed line, right? So D1 C1. So we have cut it. Now we can see in this question, so to this line, to this D1 C1 line, these two lines are exactly perpendicular, right? Exactly perpendicular. So what we do here, you take the protractor and mark for 90 degree on both sides, because these lines are exactly perpendicular to this. So taking the protractor, mark for 90 degree on both sides. Okay, you keep the protractor here, mark for 90 degree. Similarly, you keep the protractor here, mark for 90 degree. So after that, what we do, we will be drawing a straight line here. Okay, straight line here. Okay, straight line. So after that, what we do, we will take the compass, measure from D1 to A1. You can cut the arc. This is V1. Similarly, C1 to B1 you can cut the arc. So that is B1. Okay. Now similarly we have D1 to A1 also you can cut the arc. D1 to A. So D1 to A also you can cut an arc. Okay. Similarly C1 to B also you can cut the arc. Now from A to D also, by measuring from compass we can cut the arc A to D. Okay. A to D. Similarly from B to C also you can cut. Now we left with this O1 and O. You can see that you can cut that from A1 to O1 and B1 to O1 using the compass. Okay. So we are going to cut the arc. This is O1. Similarly, we have A to O, the arc, then B to O. Okay. So after cutting all this arc, so using a scale, you can join all these things. So join all these things using a scale. So this is the second diagram we have copied to the third position. Okay. So now we have to complete the final position here. Okay. So how to do the easiest method here is, okay, easiest method is, First, I'll be drawing this, writing the notations of this top face and the top face, and then bottom face and the bottom face. Okay. First, I'm finishing with the top face. You can see that. So draw a projection line till here only. So where it is the D dash. Here we have this is D dash. Okay. Similarly, you can write for C dash also. C dash also we get it here only, right? So this is C dash. So similarly, we can write project only till where our ending point we get it is A dash. So this is B dash. So similarly, we have this O point. Okay. This is O dash. Okay. So understood, right? Top face of this and the top face of this are getting here. Similarly, now we see the bottom face. So here the bottom face we have, this is D1. So here we have D1 dash. Similarly, this is C1 dash. Okay. And A1 it is here. We are getting this A1 dash here. Similarly, we have this is B1 dash, and here it is exactly here we have O1 dash. Okay. So now we have done with both bottom face notations and top face notations. Okay, this is how we have to do it. Now, for writing the final position, we have here concept that. So we have to see the nearest point to the XY line. So this is our XY line. The nearest point to the XY line, it is D here, correct? So you can see that the D is the nearest point. I will write here. So the D is the nearest point here. Okay. So nearest point is D. You can see that D is connected with which other ends? D is connected with C and D is connected with A. Okay. And D is connected with D1. It is like this. It is inclined like this. It is inclined like this. So this is what the D point. Okay, D point. So D point it is connected with C. D is connected with A, and D is connected with D1. Okay, like this. D is connected with C. D is connected with A. D is connected with D1. Okay, these are the near connected points to it. So D is connected with C, and D is connected with A, and D is connected with D1. So these are the dashed lines. Okay, first we will finish with the dashed lines. That's all the concept. Take the nearest point. After taking nearest point, see that which are the adjacent points. D is connected with C, D is connected with A, D is connected with D1. Okay, so those are the dashed lines. So D dash to C dash. So this is a dashed line. So this is a dashed line. Then D dash to A dash. That's also dashed line. Then D dash to D1 dash. You can see that from here to here. Okay. So we have drawn with the dashed line. You can see that D dash to C dash, D dash to A dash, D dash to D1 dash. Then the rest of the thing it is only with the written with the continuous line. First I am writing with the top face. Okay. The top face it is written. Similarly, the bottom face. So using a scale, using the scale, you can do it. So you can see that A dash, B dash, C dash connected with the top square, bottom face it is done. Now the vertical edges, say from A dash to A1 dash, B dash to B1 dash, C dash to C1 dash. So straight vertical line. Using a scale, you can do it. Okay. So C dash to C1 dash. Similarly, we have B dash to B1 dash. Okay. So this is what we did. Now we have to draw an axis line. Say axis line from O dash to 1 dash. So we are showing with the axis line. So understood, right? So how to write the final position here it is. First take reference nearest point XY line D. Okay, 1 point. D is connected with C, A and D1. These are the dashed line. First we have done with the dashed line. d dash to c dash, d dash to e dash, d dash to d1 dash. After that, what we did? So after that remaining part we have written with a continuous line. Okay, so that's how we complete the first problem in projection of solids.